Well, hey everybody. I promised you a project utilizing all the stuff we've learned so far in the microcontroller series. So today I'm thrilled to introduce to you my latest DIY Eurorack module, G8R. In this video, we're going to dive into the hardware and circuitry behind G8R. We will explore its features and discuss different possibilities for how we would use it in our modular setup. All right, so what is G8R? So G8R is a Eurorack module, obviously, and it is a Eurorack module that focuses, or rather has emphasis on gate and trigger events. So these would be things that you would want to do to, say, like trigger your drum modules, for example. G8R has 8 outputs. Each output can send a gate or trigger signal. G8R has 4 CV inputs. 2 of them are being used, or at least they're labeled as CVA and CVB, and the other 2 are reset and clock. It also has a MIDI input and a MIDI output. G8R has a encoder with a push button, and then an additional button with an LED. Here are the files for the PCBs. One thing to note here is I didn't use the Funky Kong jacks, and for a reason. I didn't use them because 1, I needed stereo jacks, and 2, the footprint was a little bigger than I want. I tried to use the stereo ones first, and they took too much space. So instead, I opted for the little circular ones, which are actually a little bit cheaper, and they take less realty on the board. So I was able to put the LEDs really close to these jacks. So that actually worked out really well. And these two jacks, they have this extra ground connection here. And if you look, these are actually connected together. So what this means is that if you place the part so that the ground pin is connected on the top here, that is going to be TRS-A. And if you put it so that the ground is on the bottom here, that is TRS-B. The schematic for it is actually quite simple. And we've already covered all of this stuff, right? And well, except for this encoder. But if you see what's going on in this encoder, that's just a button. And these are just connected to the pins. So there's nothing really special about this, right? Only thing is that there is this capacitor over here, and that's just to help with the debounce from the physical bouncing of the switch of the button here. This MIDI part is what we talked in the last video. The inputs, they've all been conditioned so that they can take CV. And the reason why I did that is because if you can take CV, you can take gates and triggers, right? We're just going to be reading just the rising edge instead of reading the whole state. And yeah, we have some LEDs connected to the pins. They don't draw a lot of current, so that was fine there. But the actual gates themselves, I am buffering them with this buffer IC right here, this driver. That's the 74HC541. And then, of course, they are connected to the different jacks. Nothing much more going on over here. This is just the little mounty bits that I use for the panels. And this is just what we have in the power supply. The power supply, I'm taking power from the Eurorack module. And then I'm using that 12 volts to then regulate it down to 3.3 volts, which is what we use to power the Blue Pill microcontroller. I am also using the Zener diode here as a second regulator. And all this is doing is just regulating down to somewhere around 6 volts. I marked it here so you can either use 5.6 volts or 6.2 volts. Zener diode, it just needs to be above 5 volts and below something like 6.5. What we're using it for is actually just to power the driver. This cannot take 12 volts, so we need to regulate it down to 6 volts. And that pretty much is it for the hardware. So what does this all mean? Why bother? Well, it's hackable. We're going to write the software for this thing. So far I have written 3 modes for this. The first mode is essentially a clock. When you set the clock, the tempo down to its lowest setting, it will go into external clock mode, and you can sync it. You can use an external clock instead of the internal clock. Also, if you have MIDI input connected, then the module will prefer the MIDI input to sync the module. Gates will automatically trigger every quarter note, but by single pressing the encoder and turning it, you can select different clock divisions for that trigger, and it will send pulses on different intervals. Mode 1, it is just a MIDI to trigger converter. It works on MIDI notes on channel 10. The channel is selectable, but the notes at this point are not. I'm just using modular for this, and I'm starting them at like C2, I think. The next mode is similar, but instead of reacting to strictly to notes, it will sync the gates to the MIDI channel. So regardless of what note you play, as long as it's in one MIDI channel, and that MIDI channel is 9, for example, it will play on the channel 1, on gate 1, right? And then 10, 2, 11, 3, etc., etc. I'm actually thinking of combining those 2 modes into one and using MIDI Learn instead, because we're able to save to the EEPROM on this. So I am planning to open source all of the files, the hardware and the software. However, the software for it has grown pretty organically, and so it's pretty messy. So I am in the process of refactoring the code and trying to make it a little bit more user-friendly, more developer-friendly. When I'm done with that, I'm going to make another video and walk through the code and try and explain it to everybody to see about collaborating, right? I think that we can make this module even more awesome than it already is. All right, so tell you what, let's see this thing in action, and then at the end, I am going to just do a little time-lapse video of the building process in case anybody wants to build one. All right, guys, until next time, stay creative, and I'll see you later. you.